In this video, I will give a short overview of Interferometer Lab, an online tool for defining an interferometer array, exploring the resulting transmission map, and evaluating observation windows for real exoplanet system. In this first panel here, you can select which architecture you would like. For example, you can have a triangular one, and you can then change the parameter of your layout with these selectors, or you just type in a number. There are some different ones to choose here, but we're gonna select the live architecture for now and leave all these parameters as they are. In this next panel, you can select your planetary system. For example, you can choose non-system to only get the transmission map. You can have this mock system with different parameters. For example, the stellar distance, inclination, or semi-major axis. Or you can choose a real system while selecting this NASA real system. Here in the search box, you can then type in whatever planetary system you would like to choose, for example 51 PEC, and it takes then a couple of seconds to load this system. Up here you get all the information of the system, and down here, if there are any planets, you get them listed here. For 51 PEC, there's only one planet, 51 PEC B, and then down here you get all the information of the planet. In this next panel, we get the transmission map. So we can either choose a simple mode, or for some of the architectures, we can also choose this advanced nuller. The advanced nuller, all the mathematics and theory behind this is explained in this paper linked down here. And here we can choose either between a transmission map or a kernel map, for example. You can see the difference then here. But we're going to choose the transmission map. You can also select a different wavelength or a different field of view. We're just going to leave it like this for now. And then in the last panel, you can get the observation windows. So what you have to do here is you select a start date and an end date. Then the sampling cadence, which is the amount of minutes the algorithm is going to take a snapshot of the system and evaluate whether we can observe it or not. You can also change the visit duration and the minimum relative transmission which is required. Again, you can just type in a number here, or just use these buttons. And then the last thing is the sun exclusion, so which is basically an angle on which the planetary system has to be away from the sun in order for us to be able to observe it. Then with this selected array and the parameter for the window, we get all these possibilities where we could observe the selected planetary system. All these green shaded areas is if there's a feasible window, and the orange dot indicates the best window in the given time duration. Here we can also select for the transmission versus time instead of the separation of the planet from its host star. This dotted line would be the 90% which we just said before, this red dotted line. And we can also have the scheduler priority versus time, which basically just gives us all the possibilities where we can really observe the system. Down here we get the information for all the window, which we can observe the planet. And if there are more, they are saved in the background but not shown here because sometimes it's going to be a lot. But then if you click this export PDF, it will take a couple of seconds to generate a PDF, which then stores all this information in the background, and we can have a look at it later. It shows the system and configuration which we have chosen, which planet we selected, all the observation settings, then the best window, and all the other windows which is possible to observe, and then down here the plots as well. Thank you so much, and if you have any more questions, please check out the manual which is linked here, and also the under tutorial you will find more in-depth videos.